You're welcome once again to Sir Majesty Easy World Science channel. Nice having you again. Please, if you have not subscribed, just click the subscription button and also the notification bell so that when we have upload, you'll be notified. In this video, I'll be handling a set of specimens concerning chemistry titration, a titration between tetraoxosulfate 6 acid, that's H2SO4, and sodium triisobicarbonate 4. With the specifications you see there on the screen, you are told to actually, this video is mainly for teachers, and this video will contain the actual molarities of the acid and the molarity of the base also. Then with the endpoint, then the likely questions, of course. So you are in the right place if you are looking for the perfect guide for the chemistry teachers on how you go about it to know the actual molarity. So using the specification there on the screen, they say 150 cm cube of tetraoxosulfate 6 acid solution in a corked flask or bottle labeled AN. These should all be the same, containing 2.20 cm cube of concentrated tetraoxosulfate 6 acid per dm cube of solution. That is for solution A. Then for solution B, that's very simple. Where we have job to do is in the solution A, but solution B says 150 cm cube of sodium triisobicarbonate 4 solution in a corked flask or bottle labeled BN. Remember, the N is actually the candidate's registration number. These should all be the same, containing 3.6 grams of sodium triisobicarbonate 4 pellets per dm cube of solution. So we go first of all, this will be very brief and straightforward to the point. Yeah, the first one we are asked to measure 2.20 cm cube of concentrated H2SO4, although they did not specify the percentage concentration of this H2SO4. But if this happens, you assume the highest possible concentration or the most available. So the percentage concentration of H2SO4 is usually 97 to 98%. That's a volume by volume. So 2.20 cm cube of concentrated H2SO4 represents exactly 0.04 mole per dm cube. So 0.04 mole per dm cube is the Ca, that's the concentration of the acid. Then that of the base, which is sodium triisobicarbonate 4, they say measure 3.6 grams of the sodium triisobicarbonate 4 pellets and dissolve in a given that's in 1 dm cube of the solution. So you just know how to convert this gram to mole, which means you divide the mass by molar mass. That means 3.6 divided by 106, because 106 is the molar mass of sodium triisobicarbonate 4. To enhance the easy learning and teaching of chemistry in schools, in universities, secondary schools, in research institutes. So this majestic periodic table, demand and special demand, as you can see that space there highlighted, that is where you can include the name of your school, or if you are dedicating it to anybody, you can write there, because you can print it to any size you like. In a majestic size, the resolution will never be affected. So it took me about 3 months to design and provide these informations, but thank God the table is here. What made me to design this is that I discovered that these tables I see in the internet, the one I see in the market, they are not as informative as I want. And then some of them are not updated. Some still retain the fact that we have, there are like, some still see promentum has not been radioactive. Some might see them as artificial element, but it is still is a naturally occurring element, of course. So there are some modifications that this table has been made to include, and that makes it majestic. And checking my calculator here, if you say 3.6 divided by 106, we have 0. Okay, let me take it again. Okay, 3.6 divided by 106. Have 0.0339 on the approximate 0.034, and the CA happen to be 0.04. Yes, so with these two informations, we can now predict our endpoint. Our endpoint range should be within 21 to 22 cm cube. If you use 25 cm cube of B, the average titer should be within 21 cm cube to 22 cm cube. So let's do the calculations with the equations and see how this is possible. Then you'll see the likely questions that will follow. Okay, from the information provided, the A is actually 0.04 mole per dm cube H2SO4. Then B is actually 0.034 molar of sodium trioxocarbonate 4. So we can now predict the endpoint, the range of the endpoint. Using the equation of the reaction, which is H2SO4 plus sodium trioxocarbonate 4, just like any other trioxocarbonate, when it reacts with acid, there will be effervescence, liberating a colorless gas which will turn lime water milky. There will be formation of water and salt alongside. So plus CO2. Definitely, this is going to be aqueous, liquid, then gas. This equation is actually balanced. It's naturally balanced. That means this is our Na, this is our Nb. So this is 1:1. So using the formula CAVA all over CBVB equals Na over Nb. For the only thing left unknown here is our Va. Theoretically, we have now that 0.04 times Va all over 0.034 times 25. That is only if the volume of your pipette is 25, is equal to 1 over 1, because the mole ratio of acid to base is 1:1. Then this implies that moving so fast, we have that Va is automatically 0.034 times 25 all over 0.04, which will give us, using the calculator over here, we have 0.034 times 25, 0.034 times 25, 0.85, then divide by 0.04, 21.25. So this is giving us that our Va is going to be 21.25 on the average, which means anybody using 21 or even 20, yes, to 23 cm cube is still within the range. That is when your VB is 25. But when your VB is 20, that's when the volume of pipette you use is 20, what should be the correct range of endpoint is going to be around 16 or 17. So what we're going to do is just the same thing, 0.034 times 20. So 0.034 times 20, which is 0.68, divide now by 0.04, which is 17 on the dot. So if you use 20 cm cube for VB, if VB is equal to 20, then VA will be 17, which means you can take from 16 to 18 cm cube. Anything within this range is correct. But when VB is 25, your endpoints, that's your average starter, you can start from 20 to 23 cm cube, or possibly 23 is allowed cm cube. So this is the range. Then, to remind you once again that the rule in this, if I'm the one analyzing or any exam body in titration, what they are marking is actually how your students were able to come to the close range of what you filled in the report form. So if they don't vary so much, if they don't vary with more than 0.2 from the average title you recorded in the report form, they'll get the full mark. So as you are preparing this, you prepare the standard solutions very, very well. You can watch many titration videos on this channel to see how you can prepare these standard solutions. There are many of them. Just go to the playlist that have the title titration or quantitative analysis. Then before the likely questions, I would like to show you some entertaining experiments. This channel is science channel. We handle beyond analysis for exam or teacher's guide for exam. We entertain you. There are many amazing experiments. To see more of this experiment that will follow before we see the likely questions and then the possible solutions to the likely questions, you can check for the playlist Science Tricks and Entertainment to learn how to perform these science experiments and also use it to entertain. Some of you might be graduating, you are looking for science projects, what you can do to entertain the audience or the parents that will be coming. Go through that playlist. You can now choose any one for yourself. Any one of them are amazing. They are quite wow, like you will see. So thank you. Okay, retract a little more faster. Good. Stop. Evolve. Wow, that's a nice guy. My experiment listens to me. Good one. This is majestic. Now let's go back again. Retract once again. Retract, retract. Cool, 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 cool. Yeah. Go down, down. Keep going down. And stop. Stop. Okay, that's chilling. Okay, now welcome back. From what I'm telling you, I told you that you should make sure that your standard solutions are very correct and you carry out the titration just in the morning of the examination to make sure that your average title do not vary so much from that of what your student will get, because they would severely be punished if they vary with more than 0.2. Then if your range is within 0.2, they will get the total mark, the full mark for that average title. Then there is nothing like the best endpoint. No, that's why I gave a range, 21 or 20 to 23. Yes, because there are many factors that might make our endpoint change or not be the same. So they consider all these. That's why they are actually marking what you have in the report form. And always tell your student to follow the instructions given them on the question paper. These concentrations we are giving is what we are told to prepare. The exam body might on their own change the strength of this. What matters is that the student will be marked according to their calculation steps and not according to what you assume that your teacher have told you. Because a student is not supposed to know about these concentrations. So how will you know that they changed this when you don't know the original concentration? So it's not logical at all. So tell your students to follow strictly the instructions, the concentrations, the real values given to them in the question paper. If it becomes an error during the audition and during the marking process, they will detect it. And maybe if it is a mistake beyond what they can handle, they will not repeat the exam. Rather, maybe the students will all pass. But exam bodies should not vary so much from what they give teachers to prepare. Actually, revealing those things to your students are not even the problem of Africa. If the exam body can produce or even provide 5 acids, 5 bases, 5 reducing agents, 5 oxidizing agents, 7 or 10 salts. Reveal it to the students even 2 months before the exam. Let them learn. From those 10 salts, you pick anyone and ask them. I wouldn't see how this will be a problem. It will widen the rate at which students study and learn. So that just by the way. So you see the likely questions there on the screen. There is likely question 1, and then the question 2. That one which says, yes, you can see A is a solution containing 3.97 gram of H2Y. So you see that these questions are actually designed to help you understand what you are going to expect, not that this is exactly going to be the same. So please, you stay subscribed. I will solve these in a different video altogether, where I will use it to teach in details, because the questions actually contains the possible things that one might see in titration. So I have done a video here, basic guide, or the basic informations, or the basic steps and approaches a beginner in teaching of chemistry and a beginner as a student in learning of titration should follow. But that video did not contain the recalculation steps. So I will use these 2 questions to teach it in a separate video, calculations involving titrations, or titration calculations, of course. So thank you for watching. I cannot do without you. I so much appreciate your visits, and don't forget to keep visiting. We have more majestic things for you. You can also patronize and buy this majestic periodic table I've shown you. So the majestic periodic table will help you. It's just a summarized chemistry textbook in form of a table. It is more informative than any other table you can see in the internet. Majestic periodic table took me a long time to prepare by myself, and it is highly informative, and the prices are affordable. So thank you, and come back once more, share and like this video.
Wait a minute, have you heard about Sir Majesty Easy Word? Guys, Sir Majesty took away my fear I had in chemistry and biology. You have to join the Easy Word. My name is Modia, a student in Italy. Anywhere you are, you can join us, join the Easy Word, be a subscriber. Bye, thank me later.